Hello students, and once again welcome to our channel Physi Dive, and today we are going to learn a new topic for class 10 students NCERT, and today we are going to learn about the spherical mirrors and the terms related to these particular spherical mirrors, as well as what are the conditions which takes place during the reflection process. So this is your physics teacher Alexi Rajan. So just dive in straight to the class. So spherical mirrors, we have seen two types of spherical mirrors are there, concave as well as convex mirrors. So now we have seen and we know that thing, this is a part of, so these are the two spherical mirrors, and we'll just discuss, or we'll just have a brief once again. That is, just imagine that you have a sphere with you, and the sphere is transparent, and you cut out two portions from the sphere, then you will get two part, that is, one will be like this and the other will be like this. And if you're painting this side, then the reflecting part will be bulged out. We call it as what? Convex mirror. And the second case, we have seen the reflecting part will be into or inside, so it will be curved in, and we call it as what? A concave. If you observe the diagram, you can see the reflecting part is this part, right? The reflecting part is like a cave, so that's why we call it as what? Concave mirror. We can describe these mirrors in one more term, that is, if this is a concave, if you are passing a ray of light and if you're passing another ray like this, then clearly you can see one special condition in this particular scenario, that is, after reflection both the light rays will move to a particular point, or otherwise we can say that thing, the reflected rays, let this be 1 and let this be 2. You can see that both the reflected rays are coming closer. So we call this type of concave mirror, or all the concave mirrors, as converging mirror. Whereas in the case of a convex mirror, if you're passing two rays like this, but in the case of a convex mirror, if you're having a convex mirror like this, and if you're passing two rays like this, then definitely you can see that thing, the two reflected rays will move apart. That means they are moving apart. The distance between these two rays will become larger. That is, they are diverging. They are diverging. They will not come closer. They will move apart, and we call this ray as this is ray 1, this is ray 2, or reflected ray 1, reflected ray 2. Then we call this particular mirror or the convex mirror as diverging mirror. So in the exam, if a question is asked, what are the properties of a diverging mirror, then you need to know that thing. Diverging mirror is otherwise, we call it as what? Convex mirror, and concave mirror is known as what? Converging mirror. Now we will discuss about the various terminologies related to mirrors, and we know that these mirrors are made from spheres. Just imagine that you have a sphere. Okay, just imagine that you have a concave mirror. It's a concave mirror. We are taking it as for our convenience. Okay, so we are taking a concave mirror, and you know the fact that this particular mirror is made from this sphere. Just imagine it have a center. The sphere have a center. The first and foremost term is that the center of the sphere from which the mirror is formed, we will just name or mention C for that particular point, and that particular point is known as what? Center of curvature. The center of the mirror, that is this point, that is the mirror's center, and we denote it with a letter P, and we call it as what? Pole. Now an imaginary line which is drawn through the center of curvature and the pole, which is falling normal to the mirror, is known as what? Principal axis. Got it? Now three terms are there: center of curvature, pole, and principal axis. Now the distance between the pole and the center of curvature is known as what? Radius of curvature. This is known as what? radius of curvature denoted by R. So these are the various terms related to a mirror. Now, a very important term that is known as what? The principal focus. So principal focus. We'll discuss principal focus for both the cases, both the mirrors, that is convex and concave mirror. So here we are going to take the first case, that is a concave mirror case. And this is a pole. This is the center of curvature. Now just imagine that you are passing two ray of light. Concave mirror is also known as what? Converging mirror. So after reflection, the rays will converge and they will move towards each other and they will meet at a point on the principal axis. This particular point is known as what? Principal focus. Here you need to note one very important thing, that is the ray of light should be parallel. It should be these two rays, the ray 1 and ray 2 should be parallel to principal. The incident ray should be parallel to the principal axis. Then only the converging point will be at the principal axis and we call it as what? Principal focus. If the incident rays are not parallel, then they will meet at this particular plane and we call it as focal plane, and we will not call it as principal focus, we call it as focus or foci. There are many foci, but there is only one principal focus. So what happens in the case of a convex mirror? We'll see that here right now. So just imagine you have a convex mirror here. Imagine there is a principal axis. In the case of a convex mirror, the sphere will be like this, right? So obviously center of curvature, we denote here. This is the radius of curvature, right? So we'll see what happens here. In this case, if you are passing two rays here, and then you know what type of mirror is this? It's a diverging mirror. Then definitely it will just diverge out. Diverge out means they will move apart. At any point they will not meet in real. So what happens if you just extrapolate, then you can see that if you just extend or extrapolate the reflected ray, then you can see that the rays are moving apart and they meet at a point virtually at the principal axis, and we call this particular point as what? Principal focus. Here a very important thing is there. In the previous case we can see that they meet in real, but here you can see the first ray and the second ray, they move apart, so they will not meet. So definitely we will just extend it, extrapolate backward, and we will meet there. You will get a point at the principal axis and we call it as what? Principal focus. And it feels that the reflected ray, that is reflected ray 1 and 2 are moving out, or it is originating from this particular point, and we call it as what? Principal focus. Clearly we can define that in the case of a convex mirror, principal focus is a point on the principal axis from which it seems that the reflected rays are originated, or it is originating from that particular point. So that's it about the principal focus of a convex mirror. The distance between this pole and the principal focus, which is represented by a letter capital F, is known as what? Focal length. You know the distance between the center of curvature and this pole is known as what? A radius of curvature, right? So radius of curvature is there and focal length is there. And in the case of mirrors which we are considering, there is one particular relation, and that relation is nothing but is 2 times the focal length is equal to the radius of curvature. Very important relation. That is, radius of curvature will be 2 times the focal length, or otherwise if you are given a focal length, then it is equal to R by 2. Both the relations are same only. Just imagine that this point is M and N, and the diameter of the reflecting surface of a mirror is known as aperture. So that's the case about the mirrors. And once again, one very important thing I want to just discuss here is that we are considering the mirrors. Aperture of the mirrors will be very small when we compare it with the center of curvature. So such type of mirrors are taken into consideration. So for our studies, for 10th standard studies, we are taking like that. Okay, so that's it about the various terms related to the mirrors. So we are going to discuss about the various conditions of reflection that is taking place in the case of a mirror. So if you have 2 types of mirrors in your hand, that is both concave and convex mirrors in your hand, and if you just pass a ray of light, then what will be the conditions or how this reflected rays will pass? This is what we are going to discuss in this particular session. So just imagine the first case, that is a concave case, convex mirror case we'll discuss right now. Okay, just imagine that if you are passing a ray parallel to the principal axis, if a ray is moving parallel to the principal axis, then it will converge and definitely it will pass through the point on the principal axis, and it is nothing but the principal focus. That's about the ray which is passing parallel to the principal axis. Now, the next case is that if a ray is passing through the center of curvature, then after reflection, you can see that the ray will be rebouncing back through the same path. It will just rebounce through the same path, and this is a second condition. And the third one is that if an incident ray is falling on the pole, then it will just, this is I, then equal R will be formed there, and it will just move like this. So these are the three conditions in the case of a concave mirror. And one more condition is there: if it is passing through the principal axis, then also it will just rebound back. So in the case of a convex mirror, imagine that if here you must notice that the focus, principal focus and ray are in this side, right side of the mirror. So if a ray of light is passing through the principal focus, so here passing through the principal focus means you should imagine that if this mirror is not there, then definitely it will pass through this point. So we can call it as if it will pass through the principal focus. Then after reflection, you can see it will be parallel to the principal axis. This is the first condition. And the second condition is that if a ray is passing through the center of curvature, that is, center of curvature means if the mirror is not there, then definitely it will pass through that particular point. You should imagine like that. So then definitely it will just rebounds back. And the third condition is that if a ray is moving and falls on this pole, then by the law of reflection, it will just accept that thing and the ray will just reflect. In the case of angle I is equal to angle R. So these are the various laws or conditions of reflections that happens in the case of a mirror. So that's it for today's class. So we have seen the various terminologies related to the mirrors and the conditions in the case of reflection that happens in the case of both types of mirrors. In the next class, we'll come with the image formation for the both mirrors, concave as well as convex mirrors. So make sure that you study the things clearly, thoroughly, you go through the chapters, and if you find any difficulties, you can just pin your comment in the comment section. We need your support. You like, share and comment and subscribe. So we'll see you in the next class. Goodbye.